Amol Kelkar is going to be presenting a fascinating topic. As a technologist, some of you know that Amol spent almost 7+ years at Microsoft in various development roles. Then he worked as an entrepreneur. He's also played various other roles, like as a CTO of various companies, local companies in Seattle area, last 4 years with Office Space. But his passion and journey began at UT Austin, where he did his research in computational neurobiology. And now he's back to doing research on AI again. So he's going to talk about future of AI. So it's a fascinating topic. I won't reveal much more than this, and I'll hand it over to Amol.
We all know AI, right? In university campuses and offices of big companies, it's often considered the next best thing since sliced bread. And I'm tempted to compare AI with bread. There are a lot of similarities. AI comes in different varieties, just like bread. Bread gets baked in many artisan bakeries. Those bakeries make exotic types of breads and in small batches, and at the same time we have industrial kitchens making bread by the truckloads. They're all about efficiency, and they can make bread for everybody. There's a whole ecosystem around bread. There are people who make bread, of course. There are people who help others make better bread. There are recipe books, culinary schools, and even reality shows about bread. But of course, bread has issues. It can go bad. And it takes a lot of heat to bake. And bread must be baked with precision. And alas, bread contains gluten. Everybody likes to hate gluten, right? About 1% of the population actually has issues with gluten, that they can't really eat it. Most other people just avoid it because it's a little bit difficult to digest. And bread has to be used in the right context. Actually, every once in a while I go to an Indian restaurant, I like to order sliced bread with my curry, just to see the expression on the waiter's face. But now imagine, there's this miracle bread. This miracle bread is not finicky about precise baking techniques or procedures. It practically bakes itself once you just throw some ingredients together. And this miracle bread is highly versatile. You can make a nice sandwich with it, or when you try to toss it on salad, it would turn into nice crispy croutons. You can make a nice burger with it, and it'll miraculously change into fluffy naan if you want to go eat it with Indian food. Everybody has tasted this miracle bread, but nobody knows the recipe for it. Only if we could figure out what the recipe is, we can do amazing things, end world hunger, conquer the stars, who knows what. This miracle bread is artificial general intelligence, which is human level or human-like artificial intelligence. Today's AI systems have to be tailor-made for each application separately. But AGI, just like us, would be able to tackle many different problems without actually having to tweak the system itself. So how do we do it? And how would AGI really go about solving any kinds of problems that you can throw at it? At the core, we and this supposed AGI would have to write small programs and then combine those programs together to make bigger programs, and combine those together to make even bigger programs and algorithms and whatnot. Once we make an AGI system like this that is able to write these programs and combine those programs together to solve problems, eventually what's going to happen is it's going to end up writing an AGI system that's slightly better than itself. And once that happens, that is what is referred to as technological singularity. It is a point or a process where AGI would improve itself so rapidly and to capabilities completely beyond our comprehension, so that there's no prediction of what comes next possible. So before we look at what we are missing from building an AGI, let's look at what AI can do for us today. Can you identify any of these people? Sorry, that's a trick question. These are not real people. These are faces generated by a deep neural network. Last year, Google Duplex, earlier this year actually, Google Duplex was announced, which is a system that can make phone calls on your behalf and have a conversation to, say, make a reservation for you. So here's a quick demo of how that sounds like.
See, how may I help you?
Hi, I'd like to reserve a table for Wednesday the 7th.
For 7 people?
It's for 4 people.
4 people when? Today?
Next Wednesday at 6 p.m.
Oh, actually we reserve for like after like 5 people. For 4 people you can come.
How long is the wait usually to be seated?
For when, tomorrow or weekday or?
For next Wednesday, the 7th.
Oh no, it's not too busy. You can come for 4 people, okay?
Oh, I gotcha. Thanks.
Bye bye.
AI is getting really good at fooling us. And, yeah, it is creepy. And it is getting better at an exponential rate. The game of Go was considered to be an impossible game for computers to solve, because it has so many potential moves at each step. Computers could not think beyond a few steps. But 2 years ago, Google's DeepMind created a program that was able to beat the best human player. And they did it by training the program on thousands of games played by human players. So one could say that, okay, maybe the program just learned techniques that the human players had done in their games and extrapolated from that. But last year, they designed a new system called AlphaZero. Now this new system started with only the rules of the game, no other data. And all it did was to play against itself. And within a couple of days, it became the best Go player. So this level of exponential improvement starts to become hard to fathom where this might go. But AI is still not intelligent yet. AI still lacks some core facets of intelligence that we as humans show. AI can be fooled really easily. A couple of years ago, there was this paper where they created these fake images that the best image recognition systems at that time recognized with high confidence as penguin and starfish in baseball and so on. And a cynic like me would say all the AI systems that are being built are so fine-tuned by the AI engineers. They're setting what kind of architecture it's going to have, how long it's going to train, what kind of data it's going to train on, and they're doing this tuning across many sets of parameters and picking the right set of parameters to then say, hey, look at this AI, it's solving this problem. But who is really solving the problem? There's a possibility that all that setup has given an unfair advantage to the AI for solving that one problem. And of course, as we all know, there's something more to human intelligence than what AIs can do right now. I'm going to play this short video. This was an experiment done by a psychology team, I think in 2006, where you'll see the experimenter, who is this person in the red shirt, and the participant in this experiment is this 18-month-old toddler who is standing there in the corner. Let's just watch what happens here.
Oh. Oh. So?
We think this is a natural way of behaving for an 18-month-old. And it seems so fluid, so automatic, so effortless. But when we actually start thinking about what all must have gone inside his mind, it's a completely different story. If you think about what all went through his mind, he's observing the world around him. He's able to recognize things, objects, and people, and books, and closets, and the fact that this person is holding the books. Then he's able to look at a sequence of these images as they're coming into his mind and somehow stitch together this story that this person is carrying books with him and he's moving towards the closet. Then something almost miraculous happens. He's able to read the mind of the person. He has a model of the person's personality, his desires, his goals. And he's actually able to predict that, hey, looks like this person wants to put these books in the closet. Now, with that in mind, he also has a really fine-tuned physics engine running in his mind, telling him that books cannot pass through doors. That sounds like a very simple fact for us, but for computers, or just to really figure out what's going on, that is a hard thing to do. Books cannot go through doors. Doors need to be opened. He then knows that the person is not able to open the door because his hands are occupied. That's another level of being able to put yourself in somebody else's shoes and experiencing the world through their eyes. Once he makes that determination, he then has to figure out that I exist as a person in this room and I have this phenomenal capability of making things happen. Right? And then he's able to place himself in that whole flow of activity that this person is doing, figuring out that, okay, he can open the door. Then he generates a highly complex set of muscle motor neuron firing sequences that makes him go over there, pull the door open, and at that point, he makes sure that there is space in the closet, and the closet looks like something that books can be put into. And then he shows a phenomenal capability of awareness of the surrounding. He knows that the person needs to go complete his task and put the books in the closet. But the path would take him through where I am right now. So he steps back to make room for that person, and then he just makes one eye contact and says, "Here you go." What a phenomenal set of things that are happening in that little child's mind. This is the challenge in front of today's AI. Turns out a lot of the missing pieces that we could list are to do with our consciousness. Awareness, common sense, reading other people's minds, a sense of self, and a drive to act. All of those are different facets of what we consider our unique consciousness. Let's just focus on two particularly important things, right? One is perception, of basically observing the world and making inferences about what's out there, and selfhood. Okay, I'm going to play a garbled audio and just listen to it intently and see what words pop into your mind. Anybody recognize what's being said? It's really hard, right? It's just complete garbled sound. Now I'm going to play the clip before it was garbled.
John Harris, Jordan Peterson, and Sadhguru walk into a bar.
Now let's listen to the garbled audio again. What is going on here? So our common understanding, or the way AI systems are built, is essentially this. You bring in some input, in this case audio signal, run it through some neural network, and out come words. But this cannot be true, because when you heard the same garbled sound the first time, no words came out. And they came out perfectly well the second time you heard it. Turns out, in the last 15 to 20 years, neuroscience has made significant advances in understanding this facet of our brain. We start with words. So we start with words, we use our neural network to generate audio signal. And then we just compare with what's actually coming into our ears. They happen to match. I must have heard those words. Now let's talk about the second aspect of consciousness that we're looking at, which is selfhood. All of you right now are experiencing this highly immersive 3D movie that you, as an individual, is playing the central character. And this sense of self is so strong. We almost take it for granted, but we shouldn't. Because psychologists would tell you that all different attributes of your selfhood can be challenged. So what are those attributes? Self is the experience of having the body, being the body, having this first person point of view on the world, and experiencing the ability to act in the world, and the experience of knowing that you are the one who made something happen. All these are different aspects of your selfhood, and all of them can be really easily challenged. So I'm going to show you an experiment. You can do this at home. The subject in this experiment can't really see his own hand. He can only see the rubber hand. What happens when the experimenter keeps touching both those hands, the same fingers, the same motion, that after, say, 30 seconds or 40 seconds, this person actually starts to believe that the rubber hand is actually part of his own body. So the illusion is getting set. What is happening here? Our sense of what is part of our body versus what is not is getting challenged, and challenged so easily. Now if you look at this through the lens of the same type of predictive mechanism that we looked at for our perception, this is what we get. We start with our model of what our body is. That model will predict that, hey, this is a rubber hand, not part of my body, which will make prediction that I should not feel any touch when somebody touches that rubber hand. But hey, I can actually feel when the rubber hand is getting touched. What's going on here? Of course, the experimenter is also touching his real hand. That's what's actually happening. But he has no way of knowing because he can't see that. So now, brain sitting inside this skull and only looking at the signals that are coming in has only one way to reduce this prediction error. And what is that one way? I have to change my model of what my body is. Maybe this rubber hand is part of my body. If that were the case, then I should feel touch when somebody touches the rubber hand. Oh, yes, I'm feeling touch. No prediction error. Everything is right with the world. If we look at many different aspects of consciousness, many of those can be explained with this type of prediction error minimization framework. So at i3ai.org, which is my lab, I'm trying to build models that use this type of predictive coding. Trying to bring in aspects of consciousness into AI models will possibly bring us all those good human-like intelligent attributes to that AI. But at the same time, it might help us understand our own psychology better. For example, this proposed network architecture has these properties where the units on the right-hand side, if they somehow malfunction or deficient, this network should hallucinate. If the ones on the left-hand side are deficient, this network should feel as if it is watching a movie rather than experiencing what's coming in. And all those, the 0 and the 1s at the top, I believe could represent the signal of consciousness that is generated by our brainstem. The idea is that maybe we can find answers to the deepest questions about our own psychology by exploring models like these. What about machine consciousness? We don't know yet. There's one aspect of consciousness that we don't have a really good handle on, which is the phenomenal consciousness, which is our ability to feel. So we're not sure about machine consciousness. But if we follow a path towards AGI and potentially machine consciousness that I'm trying to do in my work, AI of the future will be a bit more human. Thank you. Questions? Yes, please.
What about pain?
Pain. Yeah, that is the feeling part of it. We know a lot about pain, and we actually know a lot about the neuroscience of emotions in general, but the question of whether we can actually make machines feel pain is still out there.
So how do you teach a common sense to the machine, which you narrated exactly in your video?
Common sense is really complex. What common sense actually is the ability that we have to process many possibilities forward and picking the one that actually makes most sense. And because we have this predictive model in the brain, which the whole job of that is to keep hallucinating things. So internally, what most likely is happening when we're talking about common sense is that we're actually producing many different movies or many different scenarios and picking the one that has the best outcome that we're looking for. So it feels like, oh, I just did it with common sense, but by doing that with common sense, you have actually rejected a lot of the other possibilities. So, yeah, not a clean answer, because it is a very different or a difficult concept to even define. Yes, please.
I'm just a bit confused, like from the whole AI perspective, are we thinking of all the other aspects, like tapping the other human senses into the machine?
I would say so. I mean, we in AI generally we use vision as the primary thing that we test and build models on, is because vision is our sort of primary sense that we use to make sense of the world, and also it is the visual pathways of the brain that are most studied and known in detail as to what goes on in the sequence of processing. So that's why you see like images and videos being sort of the primary focus for AI today. But the same principle should apply to all other senses. And once we have a handle of one sense, building a multimodal system where the senses can have their own pipelines, and at some point they start merging and talking with each other. That is something to look forward to.
So another question was, like, do we need to care about our jobs?
Yes. I mean, the big elephant in the room is that if and when AGI happens, we're essentially, not jobless, but not really needed for most jobs, right? And that's the quicker we just accept that, I think the easier it will be for us. And I'm not trying to be callous about it. It is just the way things work, right? I mean, we all know what Industrial Revolution did to all the horse carriage people, right? It's just a fact of life, and people adapt and change, and societies change, and humanity moves forward.
So any job that will be created in the AI domain is what you're saying, right? But then again, we're talking about the algorithms being so powerful that they learn themselves how to code in a better way and make the algorithm much better. So
Yeah, probably coding will be the last job for humans, because that is literally the definition of AGI is something that can code itself, right? So yeah, until then that happens, I guess the programmers' jobs are relatively safe. Sure, please.
I'm not sure I'm supposed to ask a question sitting on this side, okay?
You're required to.
But I have to say this, I got to put this contrarian skeptic hat, okay? I'll tell you why. I talked about 35 years ago. I was in Washington. My major was structural dynamics, and minor was computer sciences. Okay? And at that time, I took first one class in artificial intelligence. Okay, I forgot the name of the professor. He retired, but we had machine learning, pattern recognition, neural networks, puzzle solving. Last year, courtesy Boeing, I took another AI class from MIT. And it had pattern recognition neural network. Okay? So, in 35 years, the academic part has not changed much. Okay? Only thing we didn't have 35 years ago is the amount of memory we used to have in computers.
And processing power.
And I think I'm no expert on this obviously, because otherwise I'll be speaking instead of you will be speaking here. I think intelligence is definitely related to the amount of memory and neural networks we have. And as we say, brain cells are way too many than maybe in other networks. Okay. So I wrote like too many shots, and we can talk about it later on. But in those days, I thought AI was hyped up, and I get a feeling AI will be hyped up now, because if we try to do AI same as people, then we don't need it because we have them here. The reason I got interested in this is when you go to, say, Boeing, we're going to Mars, okay? It takes 18 months to go there, okay? You send a message from Moon, it was like 20 minutes message coming in. Now it's going to be hours and days, okay? So we need something, we thought we needed something, robots and stuff who will do that work, okay? And then my question was, okay, I guess if we need robots and artificial for that, we got all these guys. I mean, if we're going to create robots or AI just like us, we don't need it, okay? But anyway, so this is an interesting topic, okay? My feeling is, AI will not be where we think it will be in my lifetime, okay? Of course, that's not many years, but maybe yours, okay? So keep that in mind.
Thank you. I mean, you raise a lot of good points, and AI, as we know, is hyped. It's just a fact of the matter. But what's happening, though, in the last 8 to 10 years is that AI has started becoming practical, which changes it from something that academics cook up in their research labs to something that Google can and Microsoft can put in our phones, and everybody has it, right? So there's the democratization of AI. But again, that is not real AI, as in, it's not AGI. And the question whether we need or whether we should build AGI, yeah, it's a philosophical question for humanity to answer. On the practical side, if it is possible to do it, somebody will do it. And the rest of us would keep philosophizing about it. So might as well be the ones who actually do it. And this is hope. There's another. The reason that I want to build AGI is that I find AI systems highly dangerous. The reason is that they're tools, right? And you can take a tool and put it to any use that you want to put it to. And the tool is not going to say, oh, I don't think that's a good thing to do. It's just going to obey you. Now, in a possible future where the rogue people, the bad people have these powerful AI tools, we need somebody on our side that can actually watch for us. And given AI is going to probably be so far beyond human comprehension, we need our own set of super intelligent AIs on our side. And that's where AGI comes in my mind. Is that instinct of seeing somebody not being able to do their job and the drive to go and help. That is something that we need in the AIs that are on the good side.
We'll be able to take a couple of more questions, maybe one more after this. Depends on the answer too, I guess.
Thank you. So it's not about a question, but just a thought. Like, can we think of AI getting extended to augment the human power than to replace it? Instead, like our soldiers are on duty on in Siachen. Can we think of AI to augment that, or to as an auxiliary force to keep an eye on the terrorists, or even augment the power or empower our farmers working in different weather conditions? I'm generally talking about the ground level of the India. That's how I can think. I'm not scratch the color over it one, but that's how can we think of AI.
Yeah, very good point. I mean, ultimately, humans being selfish, we want to build things that will end up helping us, right? And I mean, if we have AGI systems, or even fairly advanced AI systems, they can be deployed in all those situations and to keep humans out of harm's way. I mean, that's kind of sort of the natural application of AI.
Yeah, I mean, day-to-day activities like booking an appointment for haircut is like something which is making us more lazy, but this is something, we can think of really, empowering the beyond human power.
I think the applications that we see coming out are sort of glimpses in the abilities of what things can be, right? The same duplex system could actually be used on the front lines to communicate between the soldiers and their headquarters, or giving the headquarters automated status updates. So it can all fit somewhere, and these are all just capabilities being demonstrated. Okay, looks like no more questions. Thank you so much.